Hello, my lovely second grade students. How are we doing today? I am so excited to learn with you. When we learn about new topics, do we ever come across a word we don't really know that is related to the topic? Or do we have questions that we need more than the sentences we are reading to get the answer to? I know that I often do. Before we start reading our book, we are going to take a moment to review different parts of our textbook. First, we have the glossary, which gives us definition to words. But sometimes the glossary doesn't always have all the words in our book. Sometimes our books have pictures in them that also help us understand unfamiliar words. We can use the pictures to see if we can picture what is happening in the text. Lastly, we can use diagrams to see if we can understand what the author is trying to tell us. Today we are going to use our book about planets to look at pictures, the glossary, and diagrams to understand what the author is telling us. And at the end, you will be able to present some type of information to me with information that you found from a diagram, a picture, or the glossary. We are going to start on page 12 to read about our universes. As I read this page, listen closely to see if there's anything that is a little questionable to you. To give you an idea of how big the universe is, let's look at light. Light travels faster than anything else in our universe. It can travel 186,000 miles, about 7 times the distance around Earth, in 1 second. In 1 hour, light can cross 670 million miles. The universe is so large that light from the farthest parts takes billions of years to reach us. The observable universe is everything we can see with our eyes and telescopes. Scientists study light coming from an object to measure how fast it is moving toward or away from us. If the object is a galaxy, scientists can use this speed to figure out its distance from Earth. These measurements help scientists understand how large the universe is. Scientists think that the observable universe may reach 46 billion light years in every direction. While I was reading, there was just some things that I'm still not very sure what the author meant when they talked about observable universe. I'm going to look at the glossary to read the definition to see if that will help me. The part of the universe that can be seen from Earth or from telescopes in space. Oh, that cleared it up for me. Now I understand. If a word is bolded in our text like this one, what does that mean? It can be found in the glossary, correct. Let's read more about galaxies now. Spiral galaxies. A spiral galaxy is shaped like a disk with arms that spread out from its center and circle around it like a pinwheel. Stars and the arms move around the spiral galaxy's core or center. Spiral galaxies have many young, hot stars, as well as lots of gas and dust. Most spiral galaxies have a ball-shaped clump of stars in the center called a bulge. The bulge can be seen both above and below the disk. When I read about spiral galaxies, I got a little confused about what it's shaped like. I think I can have a good picture of it if I look at the picture they provided. That helped me a lot. When I looked at the picture, I really understood what the author was trying to tell me. Another way we can decide what the meaning of words are or confusing sentences is going back to the previous sentence or looking ahead at other sentences to help us understand. Now we're going to talk about it together. We can read about the Milky Way together on page 18. Our galaxy is called the Milky Way. Why do you think it has that name? Because so many people think it looks like someone has spilled a milky stripe across space. The Milky Way is about 13.6 billion years old. It started to form shortly after the Big Bang. Our galaxy is part of a cluster of about 50 galaxies called the Local Group. The Andromeda galaxy is the largest in the group. You can sometimes see it without a telescope. Galaxies are many different sizes. Some have trillions of stars, whereas others have only as few as 100,000 stars. The Milky Way has around 200 billion stars. Astronomers measure distance in space using light years. 1 light year is equal to how far light would travel throughout space in 1 Earth year. That distance is 5.8 trillion miles. That was some interesting facts that we just learned. Can anyone tell me what we know about this bolded word? Think and share with your partner, and then we'll have a friend tell us the answer. Gia, you did so good at recalling that from your memory. And remember, friends, we need to raise our hands before we talk. Let's keep going on to stars. Stars are created in a large cloud of dust particles and gas. This cloud is called a nebula. Dust and gas clump together in a cloudy ball. This ball is a newborn star called a protostar. A star is born. The middle of a protostar gets hotter and hotter over time. The center of the star is made of gas called hydrogen. As the center of the protostar gets hotter and denser, a process called fusion causes the hydrogen to turn into helium gas. This change makes a lot of energy. The energy gives off light and the star begins to shine. The star is now an adult. An adult star, including the sun, can burn for billions of years, but eventually its hydrogens will begin to run out. When this happens, the star starts to use helium as a fuel. This causes it to cool, expand, and become a brighter red giant star. More massive stars have to cool and expand more than sun-like stars to shine even brighter. That is why they are called red supergiants. The life cycle of a star is a little confusing, I think. Does anyone else think so? If we keep turning some pages, we run into a picture of looking thing. Let's talk with our partners again. Gia, can you tell me what this is? Correct, Gia, it's a diagram. Thank you again for raising your hand. Can another friend tell me what the diagram is telling us? Close. This diagram is telling us what the life cycle of a star looks like. Now we are going to, I know this by reading the title of the diagram and looking back at the previous text. We are also able to picture what the author was telling us in the text. Let's keep going. Man, doesn't the sun look so cool? On the side of their page, there's a little chart of facts about the sun. Turn to your neighbor one more time and talk about some of the facts in the diagram. Can I have two friends tell me a fact from this chart? Correct, thank you. Can you point to where you found that? Good job. I'm so glad you were able to find that fact. Gia, would you like to tell us a fact? Wow, that is hot. Thank you for raising your hand, Gia. Did you also find that in the same spot? Oh, you did so well looking. For our next activity, I will have you guys work on a presentation of a planet of your choice. You will use the charts, any diagram, pictures, the text, and especially the glossary to help you learn some new facts about the planet. You can create any type of school-appropriate presentation to show me and tell me where you found the information at. You can do a slideshow, a poster, a little diagram of your own, even a little model. Anything that you can think of, but you have to tell me where you found the information at. We all did such a good job using different parts of the book to help us have a better understanding of the meaning of the text. I am so proud of all of my friends. We can use our new skill anytime we are reading any of our textbooks and we come across something that we aren't familiar with. Now we are going to line up so we can have some lunch.